Hey guys, so in this video we're going to look at operations with radicals. Specifically in this video we're just going to look at adding and subtracting of radicals. So I have some examples here from the notes and I just wanted to go ahead and work them out. But the big theme from this part up here is just that you can only combine like terms. In this example, dollars with dollars to give me a total of $7. In example 2, I changed it a little and said that if I had $5 and I found 2 euros, how much money would I have? Well, we wouldn't say 5 plus 2 is $7 because euros I can't combine with dollars. I would have to convert one of those. So I would have to figure out how many euros is equal to $1 and then convert the euros to dollars, and then I would be able to give my total. And then the last one, Ms. Moore has 10 pencils, 4 highlighters, and 7 crayons. A student borrows, we'll just assume they do not return them. A student borrows 2 crayons and 1 pencil. How many of each does she have left? And so what you would do is you would subtract the pencils from pencils, highlighters from highlighters, and crayons from crayons. You would not subtract 10 pencils from 2 crayons to get 8 pencils. Okay, so I wanted to do that example to show you how this looks before we start putting it in context of radicals. So before we start doing some examples, just recall back from the early Math 101 and from your early algebra days that in order to add or subtract, you have to have like terms. And what that used to mean was 2x squared plus 4x squared. Well, the x squareds are the like terms, so then I would say 2 plus 4 gives me 6, and then I carry over my like term, and so my final answer will be 6x squared. And how we did that back in our early algebra days, and even in this earlier of this class, we add up the coefficients and then keep the like term. So I said 4 plus 2 is 6x squared. And so in the context of this, the radicals must match exactly. And so the cubed root of the cubed root, the square root of the square root. That's the biggest thing that I see people forget, but also that what's inside the radical has to be the same as well. So you've got some steps on the screen. I would take a second to pause this video and jot those down. But the big thing is simplify the radicals. Once you've simplified them, then if you have like radicals, combine them. And you may have to simplify again after you have combined them. So let's jump in and look at some examples. So the question says, perform the indicated operation and simplify. Now all in this video are either going to be addition or subtraction. We won't hit multiplication until the next part. So example 1, letter A, says the cubed root of 5 minus 4 cubed root of 5 plus 8 square root of 5. And so the reason that I picked this one is because a lot of times students will say, oh, all of these are like terms because they have a root 5. However, the like terms in this context are only the cubed root 5. The square root 5 is a different thing. And so just like we saw with x's, if I don't have a number in front, I can write a 1. So that is 1 cubed root 5 minus 4 cubed root 5. So now I can subtract these. And 1 minus 4 is going to give me a negative 3. And then keep the like term of cubed root of 5. That number has nothing to combine with, so it is just going to fall down. And then that would be my final answer. Make sure you type it in just like that. Don't forget the cubed on the cubed root. Don't write the decimal version of these. Just keep it like it is on the screen. All right, the next one, negative 4 square root 2 minus 2 square root 2 plus 4 cubed root 5. So I haven't simplified first yet because these square root 2's don't simplify. Cubed root 5, same thing with the 5's up here. If I were to do the factor tree, they wouldn't break down anymore. And so that's why I'm really skipping the first step. All right, I'm looking for my like terms. I've got a square root 2 and a square root 2. Again, if I don't see a number, I can put a 1 right there. Now this one is negative 4 minus 1 to give me a negative 5, and then keep the like term, square root 2. That other one is just going to fall down. All right, so let's look over at C and D. So now we're going to start to add in this other layer of having to simplify the radicals first. So letter C says 4 square root 25y minus 6 square root y plus square root of x. Initially looking at this, none of these radicals match, and so at the moment, I don't have any like terms. This is going to be your first clue that I'm probably going to have to do some simplifying first. And so when I look at this radical, I can use that property that says the square root of 25y is the same thing as the square root of 25 and the square root of y. And then the square root of 25 is going to be 5. And then that square root y is just going to fall down. And so I've got the 4. And then from the simplified radical times 5 square root y. And that is that part. Now everything else is going to fall down because they don't simplify. Now I have like terms. I need to do a little simplifying first with that 4 times 5. It's going to give me 20, and then carry everything else down. Now I'm going to combine like terms because I have officially like terms. I have 2 square root y's, and so I can combine these. 20 minus 6 is going to give me 14, and then square root y, and then carry down the square root x. And then that would be my final answer. All right, I would recommend pause the video, try this next one. All right, so I'm assuming you either got stuck or you got an answer. So let's check with mine. The square root of 49x plus the square root of 36x minus 4 square root x. So again, looking at this, nothing is exactly the same, and still the first thing I have to do is go to simplifying my radicals. So I'm going to simplify these kind of off to the side so that we can see where this stuff is coming from. So the square root of 49x, we have that property that says I can split it up to the square root of 49 and the square root of x, and then the square root of 49 is 7, and nothing changes with the x. Same thing with the square root of 36x. I can split that up, square root of 36, square root of x, and then I have 6 square root x. And then the last one is just going to fall down because it doesn't simplify. Well, it's already simplified. Now, my like terms. Now that I'm looking at these like terms, every single radical is the same. The square root of x, the square root of x, the square root of x. And so now I can combine all of my coefficients. And so I can add up 7 plus 6 minus 4 is going to give me 9. And then keep that like term of the square root of x. And so in that case, it's simplified all the way down to just one radical.